In this video, we're going to explore sample data from a MicaSense Altum sensor. The dataset we'll be looking at was captured in eastern Washington and showcases a number of different crops, including apple and cherry orchards, dormant hops, and a section of alfalfa field. We'll be looking at a number of different indices, such as NDVI, NDRE, and we will also look at false color composite and a thermal data layer. There are many other layers included within the dataset. To begin with, we will need to download and install QGIS, download sample data from the MicaSense website, and enable Python VRT functionality within QGIS. Once this is complete, we can go on to an overview of the included indices within the dataset, and we can look at filtering raster or index values. For this exercise, I am using QGIS version 3.10, the long-term release. The latest version is 3.12, and either version will be sufficient for this exercise. In order to download QGIS, follow the link in the description below, or go to the QGIS website, the download section, and select the appropriate file for installation. Once downloaded, double-click and install in the desired location. To download the sample dataset, go to the following link, which you may find in the description below. Press enter, and a zip file should be downloaded with all the relevant files included. To enable Python VRT functionality within QGIS, open a new document, go to Settings, Options, click the System tab, then scroll down to the Environment section. Click on the green cross, and in the Variable column, add gdal_VRT_enable_Python, and in the value column, add yes. Once you have done this, press OK and restart QGIS to enable Python VRT functionality. Let's go to our Downloads folder and extract our zipped Altum data to a new directory. You should have the following layers inside. Each VRT contains Python code which runs the maths required to generate each index. Always ensure you trust the source where you are downloading VRTs from, as they are dynamically running Python code when used. If you would like to see the equation or the statistics being generated by the VRT file, you can double-click on it and open it within a text editor of your choice. Here you'll find key information such as the extent of the raster, the coordinate reference system being used, and in some cases the statistics being generated. Towards the bottom of the file, you will see the equation which is being used to generate the index you have clicked on. Within our sample data folder, there is a QGIS map document, which we can double-click on in order to view our data. Now that we are within QGIS, you can see on the left-hand side within the Layers panel that all of our indices and composites have been loaded. You will see that some layers have the designation plants and some all. In this instance, if it has all, it simply means that all valid pixels of the input have been included and generated for an index, and if it has plants, it means that it's the same index but has been filtered to only include pixels which are likely to be plants. The default layer loaded is the NDVI plants layer, which shows the normalized difference vegetation index. This is an index typically used to quantify vegetation greenness and is useful in understanding density of vegetation and assessing changes in plant health. Let's zoom into an area with high and low NDVI and see what we can find. When we look in this area here, the red values indicate low NDVI and the dark blue areas indicate high NDVI. If we toggle the layer on and off, it's clear to see that the blue areas are in locations where there is green luscious vegetation, and therefore higher vigor, as expected with the high NDVI levels, and the red areas tend to be in sandier scrub-like areas where we would expect low vigor and therefore low NDVI levels. If you would like to see how the NDVI layer looks for the whole area, not just areas classified as plants, click on the NDVI all layer. We can now see the drastic difference between the scrub-like areas and the areas with vegetation across the site. The next layer we shall look at is NDRE plants. Select toggle box for it and click NDVI all off. Give it a few moments for it to load, and once it does, pan around the area to see the variation in NDRE. NDRE, or the normalized difference red edge, is sensitive to chlorophyll content in leaves, variability in leaf area, and soil background effects. Generally speaking, soil has the lowest values, unhealthy or stressed plants medium values, and green healthy vegetation has high values. It can be used in many applications, such as stress detection and determining plant vigor. As before, feel free to pan around the area and see how the NDRE values differ across the site. Remember, we can also click NDRE all to see how all pixels are classified using this index. When you look at it in this view, it's clear to see the difference between areas of vegetation and those which are not. Let's now have a look at the CIR layer, or the color infrared composite. This layer is a composite of near-infrared, red, and green. It is particularly good at showcasing the response of the near-infrared band to crop or vegetation health and for detecting water bodies. Healthy vegetation appears bright red. Unhealthy vegetation typically appears pink or a slightly washed out color. And green or brown colors typically indicates sick vegetation, soil, or man-made structures. If you would like to see some thermal data captured by the Altum sensor, click on the LWIR Celsius All tab. Once loaded, we should be able to see temperature data in degrees Celsius across the site. If you would like to find out what any of these specific values are, you can press this button here, the Identify Features button, or press Ctrl-Shift-I. You can then click on any pixel and it will pop up with a table telling you the value of your layer. It will also give you the values of other layers which are currently active. When we pan around our thermal layer, it's clear to see that vegetation has low temperature values and the exposed fields, sand and soil areas typically have high thermal values. If you want to have a quick comparison to see what it looks like in RGB, just click the layer off and on to see how it differentiates. There are a number of other layers or indices within this project to explore. Indices such as the Optimized Soil Adjusted Vegetation Index, which we can see here, and others like the Enhanced Vegetation Index, or EVI, which we can see here. If you would like more information about these indices, check the link in the description below for our knowledge portal, or feel free to leave a comment below and we'll get in touch. Finally, if you would like to restrict the range of values for any of these layers, you can do so by double-clicking on the layer of choice. In this case, I'm going to do it with temperature in Celsius. Go to the Symbology tab, and you can see the minimum and max values are populated. If you would like to restrict that range, change them appropriately. In this case, I'm going to change the minimum value to 25 degrees Celsius, and I'm going to leave the maximum value at 32 degrees. When I apply that, the range of values has now been subset to only visualize those that have been given. If you would like these values to be removed, you can click Clip Out of Range Values, and it will only show those that are valid, like so. If you would like to explore any of our other sample data sets, you can find the links in the description below, or you can navigate through the website going to Products, the sensor of your choice, and View Sample Data. You'll find for each of our sensors an orthomosaic, which has been fully processed, and you'll also find the full unprocessed data set, including raw images and radiometric panel captures.